Hi, Math 3 students. Today we are going to go over how to write exponents, or I should say fractional exponents in radical form, and how to write radicals in fractional exponent form. Couldn't think of the words there. All right, so basically kind of the gist you need to know here is that when we have something to the power and to a radical here, we can write it as an exponent, okay? So the way that we would write this as an exponent is we would say x to the power of a over b. Basically, whatever this number is inside of the radical, that's the number that goes in the denominator of the exponent, and then whatever the thing that is on the inside of the radical is being raised to, that goes in the numerator. One thing I would like to point out is that if there is no number here and no number here, what that implies, so if there's no number in the radical, that means that it's a 2. That's a square root, right? That means that it's a 2 there. And then if there's no number in the power there, that means that it's a 1, okay? So that is kind of like a default that you need to know when you write these, okay? So let's go through a couple of these. So for example here, we've got 6 to the power of 1/3, okay? So if we can see here, this is written as like 6 to, or I guess if we want to put it in terms of this like x to the a over b, that's like going to be 6 to the a over b, right? So that means that our a value is 1 and our b value is 3, okay? So if we go and write this as a radical, because that's what they want us to do here, we write in our radical, and inside of the radical, we have to put our b value. Well, in this case, our b value is 3, and then the power is 1. Now, a power of 1 we don't have to write, so the proper way to write this guy is going to be the cube root of just 6. All right? So literally all we're doing is rewriting these exponents as radicals. Okay, we're just rearranging things. So here for number 3, we work on rewriting this guy. So the guy in my denominator goes in my radical, and the guy in my numerator becomes my power. All right, now we're gonna go the opposite direction, okay? So we go ahead and we know it's gonna be 5 to the power of something. Well, my radical gives me my denominator of my exponent, so I get a 3, and my power gives me my numerator. We actually can simplify this one. So 6 over 3, we can simplify to just 2. So we get 5 squared, okay? Now, because it says to write it in exponential form, we don't have to actually write like 25 here because they want it actually written as an exponent. So we'll just leave this as 5 squared. All right, now this one, it's tricky because there's no number here and there's no number here, right? But we talked about this. When there's no number inside of the radical, it's an implied 2. When there's no power, it's an implied 1. So the way that we would write this as an exponent is we're going to do 2 to the power of 1 over 2. And that would be our answer there. All right, so let's do a couple more. One thing you have to watch out for is parentheses in these scenarios, because basically it tells you like what the exponent is being like applied to, okay? So in this case, this entire quantity, 2x, is being raised to the power of 3 over 2. So we have to make sure that when we write the radical, okay, we put the entire 2x inside of the radical. We put, and we raise the entire quantity, 2x, to the power of 3. Now, this is a 2 inside of the radical here, but we don't put that. That's kind of like writing 1x in math. Like we don't need to put that 1 there. We don't need to put the 2 there because it's just implied. All right? So this would be our answer here. If you wanted to, I would say another like acceptable way to write this, if you wanted to kind of like distribute this power of 3, you could do the square root of 2 to the 3rd, which is 8, and then we get x. All right? All right. Next one. So in this case, this one is different because only the x is being raised to the power of 2/3. So when we write the radical, we need to only put the x inside of the radical. It's going to be a root 3 and raised to the second power. Then this 4, because it's not inside of the radical, he's just going to be chilling on the outside. All right, let's do a couple more of these. Let's go ahead and try number 17 here. So in this case, we got to make sure that we essentially rewrite this guy as a exponent, right? Because now we're in radical form. They want us to write it in exponential form. So what we're going to do is we know that this has an implied power of 1. So it's going to be r to the power of 1/6. And then we can just slap this 10 out in front, okay? Now, the other way you could write this is you could put parentheses just around the r if you wanted to show that, like if you wanted to use parentheses, you 100% could. Both of these answers are acceptable. A thing that is not acceptable would be putting the parentheses around the 10 and the r, because that implies that the 10 was inside of the radical and it was not, okay? So that is bad. But either of these guys is an acceptable answer. All right, and then we'll go ahead and try this guy here. So again, we have this entire, well, I should say in this case, we have the entire quantity inside of the radical. And we remember that when there is no power on the inside, we know it's a power of 1. So we're going to do 2x, and we need the entire quantity raised to the power of 1/3, okay? You cannot write it as 2x to the 1/3, because what that implies is it's like 2 cube root of x, because then the 1/3 is only being applied to the x, which is not the case, okay? So make sure you keep that in mind there. All right. So here we're going to talk about how we can simplify radicals that have powers other than a square, or I should say have a root other than a square root, okay? So last year you guys learned how to break down radicals with the square root. Now we're going to do roots of different numbers, okay? So what we have to do is we have to, if you guys remember, right, your list of perfect squares, those were numbers like 4, 9, 16, 25, 36, and so on. Okay, those are square roots because those are numbers that you can square, those are the list of perfect squares because you can square root those numbers, okay? Well, now what we need is we're gonna need a list of numbers that you can either fourth root or cube root or whatever. And the way that you get those is you raise numbers to the power of 4. So let's go ahead and just make a list of numbers. We're going to do, because this is a fourth root, we'll make a list of numbers raised to the power of 4. So we're going to do 2 to the power of 4, 3 to the power of 4, 4 to the power of 4, 5 to the power of 4. And as you can see at this point, we are beyond this number of 486. So we will just use 16, 81, and 256, okay? So your job is to figure out what the biggest perfect fourth root is that divides into this, all right? So I'm going to do 486 divided by, and I'll start with 256. And that one does not work, okay? So then I try the 81. So 486 divided by, and then I'm going to try 81. And that one does work. So I've got fourth root of 81 times 6. All right. Now, remember how you got these, right? We got the 16 from doing 2 to the 4th. We got the 81 from doing 3 to the 4th. And we got the 256 from doing 4 to the 4th. Okay. So what this implies is that when I take the fourth root of 81, I should be getting a 3, right? Because I got that 81 by doing 3 to the power of 4. If you ever need to check it on your calculator, you can do, let's see, we would do. Oh, okay, on the TI-84, if you go to math, they have an nth root button here. So you can type in whatever your root is. So in this case, it's like a fourth root. We want to take the fourth root of 81, and you can see that that is in fact 3. So we evaluate that. The 81 comes out as a 3, and we get 3 fourth root of 6 as our answer there. All right, now let's go ahead and try number 23. So here it's a cube root, so we're going to have to go ahead and make a list of perfect cubes. So we're going to do 2 to the third, 4, oh wait, I skipped 3. 3 to the third, 4 to the third, and you can see now with 4 to the third we're beyond 56, so we can just stop there. We will use 8 and 27 and see which one divides in there. So we've got 56 divided by 27, and that one does not work, so I'm going to try 56 divided by 8, and that one does work. So I'm going to break that 56 down into 8 times 7, and we know that the cube root of 8 is equal to 2 because 2 cubed gives me 8. All right, so this guy comes out, and I end up with a 2, and I have this 7 still in the cube root. So that is our answer there.